is week 7, TEG, tables, equations, and graphs problems. Also with the algebra review, I'm going to do both of them. And also, make sure you try it beforehand on your own. And on this video, see if you can find if there's any point that you weren't so sure of. Check that. Copy it down this way, like go through step by step doing it this way. And then once it makes sense, close that, put that away, and then try again. Try again, fresh, just you, blank piece of paper, trying to get it solved. Okay, lesson 1. The height of a triangle is 3 centimeters less than twice the length of its base. If the total area of the triangle is 7 centimeters squared, then find the lengths of the base and height. Okay. Say we have a triangle. I know that's not a great triangle. Let's say there's a triangle. That would be the base, and that would be the height, wouldn't it? The base, and that's the height. And we know that the area of a triangle is half BH, half times base times height. Okay, the base is just the base, but we can rewrite h in terms of base. That first sentence lets us say it that it's 3 centimeters less than twice the length of the base. So that's twice the length of the base, and that would make it 3 less than that. So there you have it. I would prefer to use this one because that reduces, instead of using 2 separate variables, h and b, we can now just use b for both. And that helps us solve our equations. We also know a, it's just told to us. It's 7 centimeters squared. So let's rewrite this. And then instead of h, I will say 2b minus 3. And that's, of course, from here. Substitute. All right, I can get rid of the half by doubling both sides. And the half is gone. I can also, I can expand these brackets. Say 14 equals 2b squared minus 3b. Okay, I can see that it's a quadratic. There's a b squared in there, there's a b, and there's a number. Sure. How do we solve a quadratic like this if we can't do it a simple way, just by taking common factors out? Because there are no common factors all the way through. I mean, this one has no b. 2, 3, and 14, they have no, common factors that I can take out to simplify this. So let's keep on going. I would go put it all on one side. So minus 14, and make it equal 0. So everything in that equals 0. And this is normally our first step in solving this. Cool. This is, solving a quadratic when it doesn't work out our usual simple ways. I want two numbers that add up to this bit, add up to the -3. But at the same time, I want it to multiply. If I multiply it, I want it to become whatever that is, whatever 2 times -14 is. So I want it to add up to -3, but I want it to multiply to -28. Because I know it's a negative number I'm getting by multiplying, I know I should be having one positive number and one negative number, because that's how you get a negative product, right? And I think 7 and a 4 would give me that, right? To get this, to add up to this but multiply to that, I reckon a 7 and a 4. A 7 and a 4 will do it. Now, one of them has to be negative. And I think about this. There are no 2 possible answers here. There's only one. 7 has to be negative because if I add it together, I get a -3. Otherwise, otherwise I get a +3. If the 4 is negative and 7 is positive, if I add it together, I get a +3. So I know this is the way I need it to go. So here I rewrite the equation like this. I'm going to go plus 4b minus 7b. So I'm rewriting that middle bit here as these two things. I'm separating it. Right? I put the 4 first and 7 later because I feel like, because I am going to factorize that together and factorize that together, they have more common factors. 2 and 4 factorize more nicely off the top of my head, and 7 and 14 also factorize nicely not from the top of my head. So that's why I've done it this way, and I factorize just those two. The two ones that are circled here, common factors, I can take out a 2 and a b. Inside I have a b, and then inside there's a 2 in there. Plus 2, cool. Outside I can take out a -7 from both of them, and inside would be a b and a plus 2. It's a plus 2 because if I go -7 times 2, yeah, I get -14. So that's right. Cool, now I can factorize that all together because there's a common factor, the common factor being that bracket there, b plus 2. So, like I would a common factor, like any letter or any number, I take it out, that's the whole bracket, and then what's left is this. Cool. Now, because we're dealing with, so for this whole thing to equal 0, we know that either b plus 2 is 0, or 2b minus 7 is 0, which we can figure out to be b is -2, or b is not negative, sorry, 7 divided by 2, which is also 3.5. So we have these two options. Now we know this one is impossible. This one is impossible because we're dealing with a shape with a length, and we can't say that the length is -2 centimeters, so that doesn't make sense. So we know that the base has to be that. So we can say, that is the base. We just need to find the height to answer this question. The height, remember, from the top was this. It was from the first line of the question, which we wrote down here. So we just use that to find h. Yeah, which is why it was nice to have an equation like this that has h in terms of b. Because now that we found b, h is simply, actually no, let's not skip steps. Let's make it as clear as possible. 2 times, well, I can say 7 over 2. I can also say 3.5. Doesn't matter, it's the same number, which gives you 7 minus 3, which is 4. Oh yes, of course, units. So h is that, and b is that, so 3.5 centimeters. Boom, done. Question 2. I didn't actually label this as question 1. Question 1. Question 2. A uniform border is to be placed around an 8 centimeter by 10 centimeter picture. 8 centimeter by 10 centimeter picture. Okay, cool. A uniform border. Okay, cool. So there's a picture that is, I don't know, 10, 8. And there's going to be a border around it that is the same thickness all the way through. Cool. Which is why it means uniform, right? It's all the way the same. If the total area, including the border, must be 224 centimeters, a square centimeters, then how wide should the border be? Okay. So we're saying that the 8 and 10 is the picture dimensions. It's not the entire thing. Okay. Now the border, whatever that is, all of that together, that times that, should give me 224. Okay, let's start working away. Right. Now we know the area of the inside, area of the picture is 8 times 10, which is just 80. I mean, that's not hard to calculate. Cool. Now, let's say that the border width here is x, right? So that it's the, let's say it's x all the way through, right? The thickness of the border is x, or the frame. It's almost like a frame, isn't it? Cool. Now we can say it's x and it's just x all the way through because it's uniform. It's going to be the same. Cool. Now the entire area including the border is 224. But also in equation form, I would say that the area is, because it's a rectangle, right? Rectangle is Rectangle area is base times height, or length times width, whichever one you like. Doesn't really matter, or length times width, width times length. Yeah, you get the picture. So here we go. We say that would be inner bracket 8 plus 2x would be this length here. It's 2x because there's an x here and there's also an x here, right? And that would give me that full length. The full length here would be, so that bracket times 10 plus 2x. Right, just the same. Okay, let's expand. Right, so 8 times 10 is 80. 16x. Now 2x times 10 would be plus 20x. 2x times 2x would be plus 4x squared. Okay, cool. We can simplify that bit there by saying being a quadratic, I can also simplify by taking that out and putting it over that way. So I can just minus 224 both sides. So that would give me something or rather. I think it's negative 144. You can check that one, right? Right. And also for our sake, I'm gonna just flip the orders around just so that I have the x squared first, and then the x there, and then minus 144, the number, the constant, at the end over there like that. Right. It seems like I can also factorize this under a common factor. So I think I feel like I can take out the 4, right? I can take out the 4 and write it like this. That should be a 36. Yeah, I think so. Right. I mean, you might skip this line entirely. I am just being a little bit more thorough, but you might skip this line and just simply say, I'm going to divide both sides by 4, which would cancel that. 0 divided by 4 is just 0. So I'm left with this. That's a bad 9. Let me draw that again. I'm left with that. Cool. Let's factorize. Let's factorize. Here we go. I want two numbers that add up to 9, but multiply to negative 36. So I'm thinking 3 and a 12. And I'm thinking the 3 to be negative. So that's a negative 3 minus 3 with a plus 12. Yep, those two add up. If you add them together, that's a positive 9. Multiplying, negative 36. Sure. Now for that to be 0, I'm saying that is 0 or that is 0, which leads us to say that is 0 or this is 0. Boom. Cool. And we make reasonable guesses on which one makes more sense. It's the left one. This one makes more sense. Well, border must have positive width. Physically speaking, it should have some width. It can't have negative width. So x equals 3 centimeters. That's not a good x. Let me draw that again. Boom. Out of here. Number 3. If the sides of a right triangle something like that, a right angle triangle, are consecutive even integers, consecutive and even, then what are their measures? Okay, we know that this one has to be the longest, this length has to be the longest one. It's a right angle triangle. So some even number that we do not know, we will have to say, we'll pick a letter, right? Let's say x. We like using x. We could say that this is 2x, and that's a way to describe an arbitrary even number, because an even number you can divide by 2. So we say 2x is some even number for when x is a number. And the next consecutive even number would be 2x plus 2. It would be the next even number, right? As long as the x is the same on both of these expressions, we should be getting the next even number. And this one being the longest one, of course, will be plus 4, the next even number. To be honest, the order of these two doesn't really matter in this diagram, but of course this one does. Okay, what are their measures? Let's have a look. Any equations we know about right angle triangles? We can do area. We can do Pythagoras. So we get something like this. Right? When they say right angle triangle, you should be thinking Pythagoras or trig. But here we are. This should equal this plus this. We're saying this equals that, okay? Left-hand side equals the right-hand side. And this is Pythagoras, right? So this law, if you want to look it up, that is called the Pythagoras' theorem or Pythagoras theorem. I know that's bad writing. Let me try that again. Right? So that's what you want to look up if you want to know that one. And also from here on out, we're going to do a lot of probably expanding and lots of exponent laws. But let's have a look. Let's expand all of these out. So left-hand side is going to be long. So 4x squared plus that is 4x squared plus that's that one, by the way. That's that first one. The second one is I know there's not much space there, but just which is what I'm going to write here, but you'll forgive me. Yeah, that plus 4 is supposed to be in here. Just letting you know. Cool. Now we can simplify this a little bit. I mean, it doesn't really matter which one you do first, but just for the sake, because this is supposed to be slightly explanatory, I'm gonna just put these two like terms together. But otherwise, there's nothing else for me to do. Now, knowing that that's a quadratic, I want to put it all onto one side and make it all equal 0. Okay, so let's get rid of the x squared. So it's going to be 16x plus 16 equals, and I'm going to minus 4x squared both sides, which I just get 4x squared. Right, to get rid of the 16x, I'm going to minus 16x from both sides. And I get that. And then now, lastly, I want to minus 16. Now, the last 3 lines, by the way, you can choose to do it all in one go. I am just doing it step by step, each line, just to make it clear what is happening. Otherwise, I mean, it's not necessary. These 3 lines or so, you could do it in just one jump if you can. But I'm just trying to be clear. Right. It seems like I can again. If you watch what I did for for question number 2, this line here. If you look at what I've done here, you'll be able to see that I'm just going to factor out 4. So I'm going to divide both sides by 4, which I feel like I can. So I get this, this. And 0 divided by 4 is just 0. Cool, we factorize, quadratic factorization. We think of two numbers that add up to -2 and two numbers that multiply to -3. So I'm going to go with +1, -3. Right? If I add them up, I get -2. If I multiply them, I get -3. Cool. So for that to equal 0, it has to be the case that it's either that is 0 or this bracket is 0. So we're saying x is either or both, depending on what your situation is. Oops, not a -3, a +3. Cool. Now, because we were saying that 2x and 2x plus 2 and 2x plus 4 were the lengths of sides of a right angle triangle, of course we want a positive number. So the question being the three numbers, the three consecutive numbers, the numbers are 2x being 2 times 3, right, because x is 3. It's 6, 8, 10. And that's it. Question 4. A piece of wood is 40 centimeters long. It is cut into 3 pieces. The length in centimeters are blip, blip, blip. What is the length of the longest piece? Okay, cool. I have a 40 centimeters long piece of wood. I cut it into 3 pieces, and now it becomes, well, you know, I am writing it like this, but I'm not sure if it is indeed the longest one or the shortest one. Doesn't really matter the order. Right? 3 separate pieces. Cool. What is the length of the longest piece? Okay, so now we have to make an equation out of this. So whatever x is and whatever these lengths are, the one thing that we do know is that when I add them all up, they should become 40. So let's write it like that. Should equal 40. Oop. Yep, I'm running out of space. And to be honest, there's no square or anything here, so I can just ignore the brackets almost. Right? I mean, if I'm subtracting any of these brackets, then maybe I do want to be careful, but since I am adding them and adding the values together, I can work with it like this, just the same. So here, like terms, I have 4x, and I have 13 minus 5 being 8, positive 8, 40, right? I can move the 8 over that side, so it's 4x, which is 5. So x has to be 5 over 4, which also is 1.25, I believe. But I mean, or you could also say 1 and 1/4. Any of these answers are valid. Doesn't really matter. But I'm just gonna stick with 5 over 4 at the moment. Okay, the question is, what is the length of the longest piece? So let's do all 3. Let's do all 3, just to be sure. So if that equation here, I chuck this value of x, the value that we just found, into this equation, it becomes 2. Which is, what is it? 2.5 minus 5, which becomes negative 2.5. That doesn't make any sense at all. Huh. All right, I'm going to have to come back to that. Maybe I've done this wrong entirely, but I am going to press on. This becomes 1.25 plus 7, which is 8.25. 6 becomes 1.25 plus 6, which becomes 7.25. Oh no, I found my mistake. That was dumb. Here, Yep, nope, that was my bad. I'm going to do that again. I've made a mistake. And I know where I've made the mistake. I've made it right here. I've made it on this line. I don't know why I divided by 8. I was supposed to just subtract. Silly me. If I subtract 8, that's just 32. And I take away, I divide that by 4, I get 8. Right, no, that's much better. Okay, cool. Now this becomes 2 times 8 minus 5, which is 16 minus 5, that's 11. Right, that's that piece. The other piece is x plus 7, which is 8 plus 7, being 15. And x plus 6 would be 8 plus 6, which gives you 14. So the longest piece is this one, is the longest. Pow! Sorry for that mistake there, but I made it. And that wraps up our 4 algebra stuff. Okay. Right. Let's do these questions. Now on to the tables, equations, and graphs. Certain strain of bacteria doubles every 3 hours. At the start of an experiment, there are 50 bacteria. At the rate of growth over a 12-hourly period, can be given by the formula that, where n is the number of bacteria and t is the time in hours. Okay, cool. Draw the graph. So let's draw the graph. We're looking at that equation there. N equals 50 times 2 t over 3. Okay, 2 to the power of t over 3. Cool. Now, not 5, 50. There it is. Okay, when t equals 0 at here, when t equals 0, that's at this point there, t equals 0, all of that equals exactly 50. Let's change the color just to make it clearer. 50. Okay. And we're saying that it doubles every 3 hours. So we don't even need to work too hard on that equation, but we could still do it. If it doubles every 3 hours, let's work it out. Let's just prove it. Let's just check. Let's put in t equals 3 for that part there. So it should be 50 times 3 over 3, which is just 1, isn't it? 3 over 3 is just 1. So 2 to the power of 1, that's just 2. Times 50 should be 100. So yes, it has doubled. And you can definitely try this on your own, and I recommend it, but just for the sake of time, I am going to just carry on. In 3 hours, it doubles again. And in another 3 hours, it doubles again. And in another 3 hours, it doubles again. And I should be getting okay, sorry, that was really bad. A curved line that grows ever steep, right? Steeper and steeper as we go. That's it. Next question. How many hours did it take until there were more than 250 bacteria present? You can sort of guess on the graph, right? So around 7, but then you are leaning on your hand-drawn curve, which is perhaps maybe not as reliable as you might hope. So let's use some algebra. How many hours did it take until there were more than 250 bacteria present? So let's say n is 250. Now, remember, we don't even need to actually work this out exactly. If you read the question carefully, it doesn't actually ask us to do anything that algebraically difficult. It doesn't say when does it exactly hit 250. It says how many hours until there were more than. So the thing is, we can try some. So let's try around these areas, around 6, 7, 8, 9. Let's try that. So 50 times 2. Now I would probably start with 7, but I'm just going to start with 6 just to be sure. 6 divided by 3, which is just, oh yeah, this is n, by the way. This is n. 50 times, that's 2 squared, which is just 50 times 4, which is 200. So not yet. This was t equal, oh, sorry, this is t equals 6, by the way. 6 hours. Okay, let's try 7. Let's try t equals 7. N equals 50 times 2, da 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 da. Yeah. Sure. Now, mind you, you have a calculator for this bit. For the algebra part just before, we were not using a calculator. But for tables, equations, and graphs, we are using a calculator. So you can go figure out what that comes to using your calculator. And that is exactly what you're expected to do. So let's see what that comes up to. Let me just grab my calculator, because there it is. So 2 to the power of, and I'm going to say 7 divided by 3. Right, I get some number, I time by 50. And actually, yeah, I'm not even going to write that. I'm just going to put that into my calculator, and I get 251.98. But I know that's the number of bacteria, so that makes no sense. I'm going to round that up to the nearest whole number. So cool. So how many hours did it take until there were more than 250 bacteria present? It took 7 hours. So starting from 7 hours, it seems to be more than 250. And there we have it. 3. What was the percentage rate of growth of the bacteria each hour? So this is an interesting question. Now, we said it doubles every 3 hours, right? So when t is 3, the 50 at the front there only refers to the beginning point. We are just growing the number that is 50, and we're timing it by some proportion. It is growing by a certain amount. And this part here just defined in this equation as just doubling every 3 hours. That's how we've made it. Cool. So which means every 3 hours, when t is 3, so for, I know the question is about for each hour, but let's just start here. If it is 3, we know it doubles. We know the percentage of growth is, well, it's, it doubles. You can say it adds 100%. You can say it becomes 200% of the original. Either way is fine, as long as you are clear with your wording. But so let's figure out what that proportion actually is if t is 1. So for each hour, it is going up by that much. That's the proportion of its growth. So if you chuck that in your calculator, right, you get this number. I know it's longer if you've done it. If you actually do it in your calculator, it's longer. I've just rounded it up. But that's what you get. So we are saying that we can either say that it increases by 26%. It increases by 20% every hour. It will be just as valid to say, it becomes 120%, 126% every hour. But either way is fine, but that would be your growth per hour. And if you grew by 26% every hour, and I know 26 is a rounded number, but if you do, in 3 hours, you would have doubled. Cool. 4. Another strain of bacteria doubles every 30 minutes. Ooh. Assuming that t is in hours still, and that there are 50 bacteria at the start, what would be the similarities and differences between the two graphs? And give the formula for the growth. Okay, the graph formula, I'm not gonna fully draw it, but if it doubles every 30 minutes, but it started with the same amount, here, there's an important similarity. It will both start at 50. At t equals 0, they will both start at 50. So if that was the original graph, and it doubled every 3 hours, this one's going to double every 30 minutes. So that's every half an hour. So it's of course going to grow much faster. But they are going to start at 50. So you can write that in words. They both start at 50. But the 30 minutes, this new strain will grow much steeper. If you wrote that in words, that's what it would be. And this kind of graph would be what I expect. Wouldn't be enough to prove it, and it's not a good explanation if you're actually answering a question, but I'm just leaving it at that for now, because that's just writing. That's just you saying they both start at 50, but the new strain will grow much faster. Now the formula for the bacteria, the new formula would be still starting at 50, and we're growing this by a certain amount. And we're saying 2, and with something in here that would make it every time t becomes this, this whole value, including the 2 to the power of whatever, becomes, 2, so that it doubles. So remember, it used to be t over 3 up in this here, which makes it so that every time t becomes 3, we get a whole double. So for this one, I would probably go for something like t times 2, or 2t, right? Double t. Because when this in this way, if t is 1, if t is a half, which is 30 minutes, it's 2 times a half, which is just 1. So yes, effectively at t equals 0.5, it has doubled, because we're going to times 50 by 2. So there you have it. Boom. B, and this is the last one. The graph of that has been transformed to produce the graph shown. Whatever that is. Cool. Describe the transformation and give the equation. Okay, that original graph that's been written there, and that's not the graph on display. The relationship that's been written as an equation, this one, we know that the asymptote, that's not good. The asymptote, it would be on the x-axis. It would never actually reach the x-axis. It would just grow, and then it would, over this way, it'll get smaller and smaller, but it will never actually touch. It won't go across. Also, we know that, let me just zoom in there. We know that right here at 1, we know it's going to cross. Cool. Cool. So we're saying from the asymptote, which is that's the asymptote. There's a point where it passes exactly 1 unit above it, and that should have been here, but we're saying we moved it. We've moved this around. We've just translated it. It looks like they've just translated it. It seems to have just moved around, but the shape is intact. It's almost exactly the same as it was. So let's have a look real carefully. Let me just copy the... No, that's not working for me. Wait. So here it is, just so I can draw it. It looks like the asymptote is right there, right? And then we'll never actually get any lower than that. So thinking about it like that, right there, that is at y equals -2. Right? Yep, that looks about right. Now, I wonder when it hits exactly y equals -1, which is just this part here, which is this thing here, this occurrence, where it would have been the y-axis, the y-intercept, and it looks like it might be just there, right? So if we can imagine that these dotted lines would have been the original sort of the x and y axis, and they've moved it to where it is currently. So if you think about it, boom, there it is there. It has gone down by 2. It has gone to the left by 3. Now if you remember, we are just now plugging it into our equation. Oh, not E, sorry. 2. And then instead of just x, I'm going to put something here, which would be how I've moved it. So it's going to be x plus 3. So I've changed that, and that makes it move to the left by 3. And then I would minus the whole thing by 2, and that would bring it down by 2. And there you have it. That's the equation. I've described the transformation, but I didn't write it down, but I feel like that's enough for you to know where we're going. And that is the assignment for week 7. All right? All the best.